Okay, let's go in. Actually, some of my context. I am Chief Technology Officer of Unicorn, and we have over 2,500 people, and more than half of them are React developers. So we really know what we are talking about when we are talking React, because we are using React since version 0.11. It was 2013 when we first reached React. And we have a Unicorn application framework, which is a full-stack framework based on React on the front-end and user interface side. There's 5 years of development behind it, and there are currently over 1,000 components in React. So, actually, last year, I did a speak on ReactiveContext, and I was amazed by the feedback I got from you guys, because most of the feedback was, actually, it's nice that somebody on Reactive conference still talks pure React. Well, we will continue this year again, and let's take another nice React topic, and it's React custom hooks. Actually, I marked the presentation with 3 chilies, but don't be afraid. We will start mild, but as the presentation goes on, we will end up in a pure Vindaloo. Okay, so let's remember some history, how the React component was created. In the times when the major version of React was still 0, was like 5 years, the components were created by an object. There was a function, a factory called React create class, and you called that factory with an object, and it was created in a component for you. And there was all the state and props, etc. inside. With React version 15, the class syntax came into React, and there were a lot of reasoning why classes are good for components, etc. But how the time went on, another function component jumped in. First, they were purely prop-oriented, stateless, and with React 16.8, it created another logic called hooks, which allows us to do pure functional programming in React with all the things we know and like on React, like props, state, shared stateful logic, etc. So the reuse of stateful logic in the past time was done with several things. Like first one were mixins. Mixins were great for some reasons, but they are quite poorly implemented. There was a lot of overhead by using mixins in the performance, and the code dependencies were difficult as well, so they are deprecated at the moment. Then the class hierarchy came in, and so you try to share your stateful logic by the inheritance of classes, but for my opinion, class syntax in JavaScript is something quite awkward. Actually, it doesn't act as a real class in class-oriented languages. It acts somehow like it, but there are slight differences, and there are some big overhead over the syntax sugar. So I think that functional programming is more natural for JavaScript. And fortunately, React authors think the same. So they came with functional components. First, they came with header components and other, but the React hooks are, and this sentence comes from a React official React documentation. It's a pure thing, the basic thing, how to share stateful logic in React. So let's look at hooks. Hooks allow you to share stateful logic and effects. We will come later to it. And with functional component without adding any new components into your component hierarchy, because you can share some functions, for example, by higher order components, but then your component tree becomes quite deep, and there's a lot of artificial components in the tree which really don't render. They are just there to add some logic or add something to your final components which will render. So hooks can be used for many things. IOCs could be used, but they don't add any artificial components into the tree. All features that are nice in React are there, so you can still use props, you can use state, you can use lifecycle. We will come to that. And actually, something changed in the basic paradigm of how components are rendered. Because the traditional lifecycle, which is in class components, does a lot of computing before it actually calls your logic. So it depends if the component is mounted, if it's updated, if props are changed, and there's a lot of computation behind which is done before actually your component did mount, component did update, or something is reached. With functional components, it's different. React simply used the speed of JavaScript, because JavaScript now is incredibly fast. So what if we can just run the function component, because it's a function, anytime the render comes, and let JavaScript do this work, so let's do it fast. And if you want to optimize, if you want to decide if you do something on certain circumstances, let's do it in your code, in your control. So React doesn't do this anymore for you in those functional components. So this is something which is proven from many tests that is quite fast, and it's even faster than all these ifs and conditions before calling your application logic. The only problem is that JavaScript is fast, but whenever JavaScript comes to some APIs, to some browser APIs, it's not so fast as it used to be. Just a moment, I will start my timer because we have to finish on time. So hooks are another way how to do mixins and to share logic, and from my opinion, they are done well. So let's just go quickly through the built-in hooks to explain them, because we will need all of them in our custom hooks which we will build here on the podium. And actually, if you want to open your laptops and follow me with the coding, I encourage you to do so. And at the end, I even give you the URL on GitHub where you can download all the code and you can try to do custom hook by yourself. So there are three basic hooks: useState for stateful components, useEffect, which is just one hook, one component which replaces most of the lifecycle functions which are in class components. And there's, of course, UseContext for context components, so still components, the state of the component and the render of the component depends on props, state, and context. How the useState works? Basically, in the function, you call the useState hook. The hook returns you two things. It returns you the variable which contains the current state, and returns you function which you can use to update the state. And that's it. Actually, this is called anytime the component is rendered. And why does it work? Well, there's some magic behind with the hooks with React. So first time when the component is mounted, React detects that this hook is still not in scope and creates a new one for you. And the next time it comes to the hook call, it only reuses the already created object which is behind the hook. So as I told you, you are running the functions again, but they are blazing fast. And the internal logic explains or does everything behind. So this hook actually will survive, and the state of which is stored in the hook will survive the whole lifecycle of the component. And hooks heavily depend on JavaScript closures, and all the syntax depends on JavaScript closures. So if you want to use the hook, you basically use its return values. So the state, which is like here, the name, you simply render by using this variable. If you want to set the state, you just simply use this function returned by the hook to setting the state. Well, there are some things that some old habits you used to optimize your code in class component doesn't work anymore, because, for example, this function is recreated every time renders comes to the component, but it doesn't matter anymore, because the JavaScript compiler is so clever and so fast that this goes for no penalty. So there's no reason why to put this function out of the scope of the hook and to pass all the parameters to it and get the return value. It's so fast that you can create it in the scope and let JavaScript and JavaScript engine do its work, and then use the nice syntax that you can directly call the set name without passing it anywhere else. Yeah, so this is important. The other thing which comes with this, that in class components, because usually state is an object and is updated as a whole object, you usually store not just the pure state, but you derive some other variables and some other values from the state and store them as well, because it's cheap and you don't need to recalculate. With this approach, we say recalculate is cheaper than storing. So if the state is derived, recalculate it anytime. And if it's costly, if you need to optimize, there are some other hooks like useMemo or useCallback, which you can use to optimize this. Yeah. And there are some, of course, useHook for some more complex states. Well, let's go to useEffect. We will need basically those two hooks for creating our custom hook. The useEffect replaces most of the lifecycle methods that were in the class components. UseEffect is something which is called immediately after, but asynchronously, the render function finishes. In function component, the render function is basically the body of the function component, but it's always after and always asynchronous. So usually render goes, even the reconciliation of the DOM of the browser is before your useEffect hook runs. And the function which is inside the hook actually does some effect, because what you do on your component did update or component did mount, you have to do something which is not directly involved in the render, which is not directly involved with translating your JSX code into browser DOM. So you probably call some event handlers, you call some APIs, you call external functions and something like it, and a lot of those calls are stateful. So you initialize them on the component in mount, and you want to uninitialize, destruct them on component will unmount. So exactly that you can do with useEffect. And the cleanup function is a return value of your function which actually initializes the effect. We will come to this later when we will create the hook, so I will explain. And for rare cases when this is not fast enough, because this is usually so fast that even the asynchronous processing of the hook doesn't matter, and there will be no problems with your code. Actually, the user interface will feel more responsive than if you do it synchronously. But for rare occasions where there will be some unwanted visual effects, you might use useLayoutEffect, which runs synchronously. It runs after the virtual DOM of React is reconciled, but before the browser DOM is painted. So still this is in the synchronous way from your code from render before it updates the screen. But I suggest that you don't use this, only if you really need to. So start with useEffect, and if it's not enough, you can switch to useLayoutEffect. It has exactly the same interface, so the refactoring is cheap and takes nothing. But there are some rules for hooks which you have to follow if you want to develop them. The first one, that you can call hooks only on top level. So you can call them directly from functional components, or you can call them from custom hooks. We will show this. Why? Because React depends heavily on the order of the calling of the hook. Actually, when you are creating and when you are rendering components, you are not calling direct. The render is not called directly, because your JSX code translates into React create element function, and this React create element function does the magic behind. So it tracks where you are in the tree, and actually the mainstay is the second tree of hook states next to it. So it's extremely important that hooks are called in the same order than the components in the trees are rendered. And that's why you can't call them in conditions, you can't call them in loops, you can't call them in callbacks or in nested functions, because in all these incrementancies there's a danger that the order of calling the hooks will be different than the order of rendering the components. So you can call them only at top level. So what if I want to do some optimization, and what if I don't want to call the code all the time? Simply move the condition or the loop inside your hook. Because the calling of the function is cheap, I explained to you. So it doesn't matter you call the function, when you return quickly and you don't do your heavy computation, it doesn't matter, it will be fast. Okay. So, and I strongly encourage you to use linter, and there's a nice plugin called slint plugin React hooks directly from Facebook, which will help you to follow these rules in your code. There are like 10 built-in hooks. We will not explain them all. We don't need them all at the moment. I expect, it's free chili speech, so I expect you know them already. But we will show how to create some custom hooks for us. So what is custom hook? Custom hook is the way how you can share logic or some effects. Actually, effect is called because usually it was called side effect, but not all effects are side effects, because side effects is somehow unwanted. Our effects are wanted, so they're simplified the name for use effect. So your hook can do custom effects or can share stateful logic, can store stateful logic for your components, and you can reuse them between components. The convention is that your hooks should start with the word use. It's not necessary, but it's a good convention, and the linter again will check it. Your hook has to follow the rules of hooks, and otherwise it's just normal JavaScript function, actually there's one exception. The custom hook should finally somewhere call some built-in hook. Otherwise, it's not a hook. Yeah, so it will work, but it will be just common JavaScript function without any connection to React internal processing. So usually the custom hook calls useState or useEffect or some other hook to do the final step in your logic. Yeah. And your custom hook can expose any interface to component which takes the hook and which is hooked, and the interface is exposed through its return value. So you can return object, you can return primitive, you can return function or set of functions. It's completely up to you, and everything is allowed which is allowed in JavaScript. Yeah. And from my experience and from the experience of rewriting our code base to the next level of React, custom hooks can be used for most cases where mixins or higher order components were used before. So let's start with our custom hook at the moment. Perfect. We will take something which everyone understands. In most of graphical frameworks like Material Design or Bootstrap, there's some pattern of screen size or screen factor. Because of course, you can be responsive by pixel, but it's extremely difficult for a graphic designer to design and prepare such a user interface. So they usually stick with like 4 or 5 screen sizes, and they prepare your wireframes, and they prepare your mockups for those 5 sizes. And then when you write a code, you are aware that when your screen size changes from something like this to something like this, it's changed from XL to S or XS, and you render your whole component tree and render it differently responsive. Mostly, you can stay just with media query and just use your CSS to render a component. But what if it's not enough? There are many cases when you want to render completely different content on your small screen size than on your XL screen size, simply because the XL content has no sense on the small screen. There are even some technical reasons. For example, we have a chart library which is using SVG, and SVG by default is not very responsive. So if you want to have responsive charts done by SVG, you have to recalculate anytime you resize or you change your screen size. So when you do something like this and run the same code on your tablet or on your phone, you have to basically render the component and render it differently. So you need some hook, which will tell your screen size sensitive component that it needs to be rendered and there's new screen size. So we will use Bootstrap screen sizes and Bootstrap names. So we have screen size from XS, S, M, L to XL. There's a basic helper function which will check, depending on the element, by default by the browser window, what the screen size actually is, and will return you the string containing this XSS or something else. And we will implement something, some hook, which a screen size sensitive component can take, and which will tell her anytime the screen factor changes. So let's start with first, I call it naive implementation. Our hook will need useState, because it has to store somewhere that now it's XS, and until the screen doesn't change more than I don't know, 500 pixels, it's still XS, and then it's S, and then it's M. So we store it with state wherever, because this is React. We need useEffect, because we need to tell the component by some effect that the screen size changed, and trigger it by changing the state, trigger it to re-render. And so this is it. We use the screen size here, the useState here, and our useEffect has a helper function. Actually, this is the event listener, which will be put to the event in the browser. In the effect function, we add event listener for resize. And as we are aware of mobile phones, we probably know that when you have your mobile phone and you change the orientation, resize is not triggered, but orientation change is triggered. So you have to actually put 2 event listeners on 2 events if you want to switch. And we have some nice cleanup function here, which will unmount the listeners when the hook is cleaned, because this is necessary. Otherwise, we will end up with many listeners and memory leak in the browser. And we will return simply the string containing the screen size from the hook. Okay, let's use it in our components. So we have a component called box here. It's a simple one, because we have no time for creating SVG charts here on the stage. It simply takes the screen size by the hook. It's over here. And it renders a box which will contain the string of the screen size. And to make it work, and to show how it works, we create a helper function which will generate thousands of boxes. And we create our app with a simple diff, which takes these thousands of boxes and renders. Well, this is the result, and what a surprise. It takes 8.7 seconds to render. So what we did wrong? We did our effect, we did our cleanup functions, so everything should work, but it doesn't, obviously, because 8.7, it's terrible. Well, I told you that effects by default are called after the render is done, but before the effect is done, it's always clean up. So your cleanup function is called before your effect is done again. So what we actually created, it's anytime component re-renders, it will remove event listeners from the browser, like 2,000 of them, and it will add new 2,000 event listeners to the browser. And I told you, JavaScript is blazing fast, but browser APIs are not. So this is our bottleneck. This is something which takes a lot of time. So how we can help with this? This is the state, here you clean up, and here you mount it again. So there are some optimizations. I chose another hook, which is UseContext. By the way, if you don't understand context, there's my speech from the last year on YouTube, and you can watch it. So we will do some improvements. We will create a context, which will take the screen size and will propagate to components which are sensitive to screen size. We have to rename our original hook, because now it will be used just by the context provider, which will be one component somewhere on top of your hierarchy on the application level. I choose to get screen size. I'm not very proud on the name, but no time to think about it. And we will render the screen size context provider and put the screen size in the value. So this will propagate the screen size change to all components which are aware and which have our screen size hook. And our screen size hook now just calls the UseContext screen size for this. Actually, we could omit this, but I wanted to keep my code clean, and I wanted to keep the box implementation, application implementation untucked. So with this change, now it looks different. You see that the code is exactly the same. It renders exactly the same. And it takes 16.3 milliseconds to render for 1,000 boxes. So it's 2 magnitudes faster. Yeah. So I think we are done. That's okay. We can get this implementation. Actually, we could go even faster, because there are ways how to call the hook, the use effect hook, only on the component mount, and clean up only when you are mounting the component. So if you leave the state from the hook, add something like useref for storing the value of the screen size, we can even avoid this event listeners which are unregistered and registered when the screen size changes from S to M, etc. But this optimization actually doesn't make sense, because it adds like 3 milliseconds. Who cares? Yeah. So what about custom hooks? What we can use them for? For everything, actually. There are many custom hooks already ready on GitHub. There's an example of a nice repository of hooks. You can go through it, and you can check them. And you can either use them, or you can be just inspired, because I don't think we should be afraid of our own coding and just compose applications from code who did someone else. Because most of the hooks are up to 100 lines of code. So if you understand the hierarchy of the hook, if you understand closures and building hooks, the code is perfectly understandable. And you can consider if it does exactly what you need to, or you just create your or custom hook with 50 lines of code, which does something more precise for what you need. So I strongly encourage you to not just reuse, but think, study the code, and create your own whenever it makes sense. And by the way, you can check our U5 library, which is open source as well, which next generation is heavily based on hooks. So there are like 100 hooks there, and like 200 of components you can reuse directly. And some conclusions. Well, hooks are a very effective way how to shell stateful logic and effects between function components. So if you are creating a new code base, you can create it purely functional without classes, and everything will work, and you will come to no obstacles. So you can use just hooks and don't bother with classes. The function components are usually faster, sometimes much faster than class components. They are better testable. We have no time to prove it here, but you can find a lot of articles about it on the internet. And from my point of view, functional programming is much more native for JavaScript than class component and OP. So this is another good reason for it. But still, in React, class components are first class. So you can use either function components or class components. You can combine them together. You can render class component from function component and function component from class component. Everything will work, and there will be no problem. So if you are adding hooks to your existing code base, don't be afraid. You can create new components with hooks, and you can stick with your old ones and mix them together. And if you want to share my little exercise, there's a GitHub. If you just look for Unicorn on GitHub, you will find it, and the whole code and the whole working repository is there, so you can download and you can play with your first custom hook. Okay, so if you are a React developer, you can avoid hooks. So I encourage you strongly to become master of hooks. And that's all from me. Thank you, guys.